Hello everyone, a very warm kuzonko and welcome to Bhutan e-learning project. This is Doji Tropa again from Tashidinka Central School under Punakha Zongkak, and this time I'll be again taking you through one of the topics on class 7 and 8 mathematics, describing and solving linear relationship. By the end of the lesson, you should be able to describe linear relationships, use algebraic equation to describe linear relationships, define linear equation, solve linear equation using inverse operation. Okay, now first of all, let us look at describing relationship. As you can see on the board, there are three figures given, and if you look very carefully, the three figures are all boxes made up of several dots. And these boxes, the several dots, are actually forming a pattern. So this pattern can be a kind of relation, and this relation can be described using three different methods. One is table of values, another one is graphing, and the third one is algebraic equations. Okay, so the first method of describing is called table of values. So let us look at it. Now the three figures are made up of several dots. So these dots has to be represented in the form of table. So table should be of two columns, and I have kept first column for figure number represented by F, second column number of dots represented by D. So first figure, if you count the number of dots, I can clearly see there are 10, and for 2 we have 14, and for figure number 3 we have 18. So by looking at this pattern, by looking at this number of dots in figure number 1, 2 and 3, now for figure number 4 and 5, will you be able to say how many are there? Of course, I'm very sure you people must be knowing. So if you look at the difference between the number of dots for figure number 1 and 2 and 3, I think 14 minus 10 is 4, 18 minus 4 is again 4. So there is a difference of 4. So which means every figure number of the successor exceeds the preceding figure number by 4. So which means for figure number 4 we will have 22, and for figure number 5 we will have 26 dots. So likewise, as we move on, no matter how many figure numbers are there, we can keep on adding 4, 4, 4, 4, and then we will get the value. So that is called table of values. So this is the method of describing relations using table of values. Now the second one is the method of graphing. So graphing is the representation of data on graphs. So for linear relations, if we plot a graph, the graph will always be a straight line. For example, you can see on the screen the same table of values that we had earlier. I have transferred it here. So figure number 1, 10, 2, 14, 3, 18, 4, 22 and 5, 26. Now keeping figure number as x-axis and number of dots as y-axis, so if we plot a graph, x-axis 1, y-axis 10, x-axis 2, y-axis 14, 3, 18, 4, 22, 5, 26. So that will give us a very straight line graph. So that's why the relations are actually called linear. Linear basically means a straight line. Okay, so in this table of values, I have figure number only up to 5, but then if you want to go for figure number 6, 7 and 8 and so on, you can keep on extending the line and it will always remain as a straight line only. So this is the method by which we describe linear relations, which is actually called graphing method. Okay children, I hope I'm making some sense. Now the last and the third method, which is also called equation method or algebraic equation, which is very, very important. So let us have a look at it. Before I talk anything about it, can you please look at the table? The table, the same table that we discussed earlier is being transferred here, okay? But now you can see some things happening to this table. So observe properly and try to understand what actually happening over there. Okay, so now see the difference between number of dots between each figure is 4, which means the next number of dots is addition of 4. It gets added up by 4. And now if you look into the left column, you can see that the 4 is multiplying the figure number, and in order to get the number of dots, so 1 times 4 is 4, but 6, so 4 is not equal to 10, so number of dots is 10 in the first figure, so that's why we are adding up 6. And for second figure number also, 2 times 4 is 8, right? 8. From where did we get that 4? That is the difference between number of dots in every figure. So 2 times 4 is equal to 8, and 8 is not equal to 14. In the second figure there are 14 dots, so therefore we add upon 6. We add 6 on that, so it makes it 14 again, right? And then for third also, we are multiplying it by 4 and again adding 6 to get 18. And for fourth and fifth also the similar way. So by looking at this, what can you say, or what do you observe? We observe that we are multiplying figure number with 4 and adding 6 to get the number of dots. Am I right? Therefore, we can say 6 is the constant because it is applied everywhere, because it is added. Sometimes depending upon the term, it can be added or it can be subtracted as well. But for the difference that is 4, it should be always multiplied. So therefore we say figure number can be any number. In this table it is given only up to 5, but if somebody asks you calculate the number of dots in n figure, means now n, we don't know, right? So it's a variable. So therefore 4 is considered a numerical coefficient. So for this table or for this relation, now to calculate d, the number of dots for any number of figure, it's equals to 4 times f plus c, because f is the figure number and c is constant, right? So therefore the equation, the proper equation is equals to d is equals to 4f plus 6, where 4 is the coefficient, f is the variable and c is the constant. Now if I give you one example, if somebody asks you to calculate number of dots in the 20th figure or in the figure number 20, how many dots are there? Then we can simply make use of this equation. D is equals to 4f plus 6. So f represents number of figure, right? So we are to calculate number of terms, number of dots in the 20th figure. So instead of f, we can substitute with 20, and after simplification we are getting 86. So which means there will be 86 dots in figure number 20. I hope I'm making some sense. Okay, children, so some more examples. So now there are two examples, example A and example B. Actually they are relations. So relation A, 14, 24, 34 and so on. Relation B, 100, 95, 90, 85. So in this case, in these two relations, what can you say about? The first one, it's increasing. Increasing by how many? Increasing by 10, because 4 plus 10 is 14, 14 plus 10 is 24, 24 plus 10 is 34. But in the second case, what is happening? It is decreasing. Decreasing by how many? Decreasing by how much? 5. Yes. So 100 minus 5 is 95, 95 minus 5 is 90, 90 minus 5 is 85, 85 minus 5 is 80. Okay, so first let us look at example A, the relation A. So now in this case, I have used as term number and term value. Term number represented by n, term value represented by v. So term number 1, the term value is 4. For term number 2, the term value is 14. For 3, 24, and for 4, 34. Somewhat like this, right? Now if you look at the difference between the successive term values, the difference are 10. Am I right? So now, as in the earlier case, this 10 will serve as a numerical coefficient which will be multiplied with the term number n. But when these two gets multiplied, we are supposed to get the term value. But these things actually not happen. So in order to happen it, what we should do, we should either add or subtract a number so that it gives the value. So in the first case, so since difference is 10, so 1 times 10 is 10, but the value is 4, which is less than 10. Am I right? Now in order to get 4, I cannot add. If I add, then if I add a positive integer, it will be again more than 4, because it is obviously already more than 4. So in order to bring it to 4, what I have done is I have added negative 6. So why I have added negative 6? Because 10 plus times minus is minus 6, that will give us 4. And in the case of second term number also the same thing, it is multiplied by 10, again it's 20. But the required term value is 14, so we are in excess of 6 values, right? So again we have to subtract 6 from there, and that will give us 14. And same for 3 and 4. 3 times 10 minus 6, 4 times 10 minus 6. So 24, 34. So therefore negative 6 is common to all the term number. Therefore it is a constant term. So therefore for this relation, the equation will be v is equals to 10n minus 6. Now if somebody asks you what will be the value of term for term number 51? If that is the question, how will you do? Very easy. In place of n, just put 51. Just insert 51. This is because n represents term number. So v is equals to 10 times 51 minus 6 is equals to 504. So which means for the 51 term number, the value of term should be 504. Let us again look at the second example, example B, which is actually decreasing. So again we have term number and term value. So in this case, now the values are actually decreasing. So what is the difference? It is decreasing by negative 5. So which means if we take the difference, it's negative 5. Now the same thing, this negative 5 should be multiplying n, right? And then we have to see whether we are getting the respective term value or not. If we are not getting, then we have to think of a number that equalizes and makes it the term value. So let's have a look. So for first 1 times negative 5, what is the value? Negative 5, right? But negative 5 is not at all equal to 100. So our aim is to get 100. In order to get 100, what should be the number that can be either added or subtracted? So if I put negative 95, so you must be thinking about 95, right? So if I put negative 95, what will be the value? Negative 100. But over there the term value is 100, positive, right? So therefore, let's think of a number, either positive, it should be positive, that makes the term value equals to 100. So how about 105, positive 105? So if I insert 105 there, then negative 5 plus 105 is giving us 100. Now this 105 should work with all the term numbers. Am I right? Yes. So second case, 2 times negative 5 plus 105, 95. 3 times negative 5 plus 105, again 90. 4 times negative 5 plus 105 equals 85. So check whether these are true or not. Now for this relation, what is the equation now? So v, the term value, we are calculating v, right? So v is equals to negative 5 times n plus 105. So v is equals to negative 5n plus 105. So this is the equation, algebraic equation for the relation B. Okay children, I hope I'm making some sense. You are understanding something out of my lesson, what I've been teaching so far. Now this is all about description, okay? Now we are left with solving part. So before we really move on to solving, so let's look at what linear equations are actually. An equation that describes a linear relationship is called a linear equation. So far we came up with so many equations, and all those equations are examples of linear equation. For example, v equals to 10n minus 6, or v is equals to 105 minus 5n. So these are all called linear equations. Okay, so then all these equations, they are called linear equations, right? And why are they called linear? This is because if we looked into it carefully, all the variables in these equations, variables means the alphabets, right? It can be x, it can be y, it can be n, it can be v, it can be a, b, whatever. All these variables are raised to the power 1, which means the exponents of the variable of the equations are all equal to 1. That's why it is called a linear equation. So usually we don't write 1 to represent exponent 1. This is because any number raised to the power 1 is the number itself. For example, 5 raised to the power 1 is 5, 6 raised to the power 1 is also 6, 100 raised to the power 1 is also 100, and if I talk in terms of variable, a raised to the power 1 is also a, b raised to the power 1 is also b, or x raised to the power 1 is also x. So that's why we don't mention when the exponent is 1. So if I show you example, 3x plus 2 equals to 8 is a linear equation. Why? Because in this case, in this equation, variable is x. So variable x is having exponent 1, but it is not mentioned. Why it is not mentioned? I already told you. Okay, let's look at another equation or another example. X square is equals to 9. Is it a linear equation? Can I first think? Think about the definition of linear equation and then try to say whether it is linear or not. Obviously, this is not a linear equation because variable x is being raised to power 2. To be called as a linear equation, the exponent should not be more than 1. So this is a non-example of linear equation. Okay students, I hope you are still with me. We are almost coming to the end of our lesson, but we are left with one more important topic, that is solving linear equations, which is very, very important. Solving linear equation means to find the value of variable of the linear equation or any equation to make the equation true. For example, if I say 3x plus 2 is equals to 8 means here the variable is x, so we have to think about value for x that will actually equalize 3 times x plus 2 is equals to 8, right? So we have to think about the value of x. When we are asked to solve this question, it means we need to find the value of x. Am I right? So let us understand the question. 3x minus 2 equals to 8 once again. The output is 8 and the input is x, right? Output is given but input is not given. So now we have to think about, in order to produce or in order to give the output as 8, what should be the input x? So this is what we are supposed to do, and this is how we understand linear equation questions. Okay, we can also have guess and test, but that may not be possible for very complex equations, and even if it's possible, then also it will consume a lot of time. Okay, so now let us look at how to solve linear equation step by step, because guess and test that you have studied in lower classes, that may not be possible for complex equations. So let us look at another method of solving linear equation, that is using inverse operation. So the equation is 3x plus 2 is equals to 8. So which means the variable x has to be isolated, or variable x has to be separated, or we have to make it a subject, because our aim is to get the value of x. Am I right? In order to do this, we have to get rid of numbers which are there along with x. So over here we have positive 2 and 3. Am I right? So in order to get rid of positive 2 first, so we have to add a number that nullifies positive 2. So when we add that number to the left hand equation, it should also happen to the right hand equation in order to balance the equation. So let's have a look. So positive 2 can be cancelled if we add negative 2, right? So that's with plus 2 minus 2 equals to, so 8, and since negative 2 is added to the left hand side, and for the right hand side also there should be negative 2 being added. So 8 plus minus 2 means 8 minus 2. Okay, so now we are left with the more simpler form of equation. Instead of 3x plus 2 equals to 8, we have 3x minus 6, because we already get rid of positive 2, right? Again, we have to get rid of 3 in order to isolate x. Now in this case, there are 3x means x plus x plus x, 3 x's are there, and then this 3x will try to divide 6. So each x will be getting how many? Each x will be getting 2. So therefore, x is equals to 2. Now try to put that in the earlier equation, 3x plus 2 equals to 8, and see whether it is coming 8 or not. So 3 times 2 plus 2, which is equals to 8. So it's correct. Okay children, I hope you are getting something. Please pay attention and be with me. I'm left with a very small portion. Few more examples please. So next example question is in the form of fraction. 2 over 3x minus 3 over 4 is equals to 5 over 4. Now this is it's a linear equation but in the form of fraction. Now how to solve? The method is same thing. So first of all, we'll get rid of negative 3 over 4. So in order to get rid of negative 3 over 4, we have to add positive 3 over 4. So when we add on left hand side, it has to be added on the right hand side too. So because, okay, and negative 3 over 4 and positive 3 over 4 gets nullified, which means cancelled, it becomes 0. So we are left with only 2 over 3x on the left hand side and 8 over 4 on the right hand side. Now again we have to get rid of 2 over 3 because x is still not isolated. So we have to make it the subject. So in order to get rid of that, again divide it by 2 over 3 on both sides. So at last we are left with x is equals to 3. So why we are adding numbers on both the sides? In order to balance the equation. So this is the final answer, where value of x is equals to 3. Try to put that in the equation and see whether you are getting the right answer. Another example in a form of decimal. 3 plus 2.5x is equals to 9.25. This is also a linear equation. Now in this case also, our aim target is to find the value of x so that the equation will become true. So first of all, let's try to get rid of 3. So in order to get rid of positive 3, we have to add negative 3. So when we add negative 3 to left hand side, add it to the right hand side too. So we are left with 2.5x equals to 9 minus 2.5 minus 3 is 6.25. So 2.5x, again we have to get rid of 2.5. So therefore it has to be divided by another 2.5, and on the right hand side also divided by 2.5. So finally we are left with x is equals to 2.5. So this is the final value. Put that into the equation 3 plus 2.5x and see whether you are getting 9.25. If you are getting, then it is true. Okay, that's all I have for you today. And before I really conclude, let's try to recollect what we have learned. So today, in today's lesson, we have learned about how to describe relations using table of values, graphs and algebraic equation, how to get the algebraic equation from the table of values, what are the linear equations, and how to solve linear equation using inverse operation. Okay, my dear children, thank you very much for being with me. I hope you all enjoyed my lesson. That's all I have for you today, and until then, this is me saying goodbye and see you in our next lesson. Kadimcha.